Hello, everyone. I am very excited to be here sharing with you today. My name is William. For quite some time, I have been working and learning about natural language processing and the different use cases that it can unlock. I am a strong believer of the role of technology in education. And having said that, I want to share with you today two stories about different projects that I have worked in the past and currently working that involve virtual assistants, chatbots, or bots. And I will give you one example of each one of them. So let's get started. But before we start, it's very healthy, let's say, to define the problem. They say that a well-defined problem is 50% solved. So what are the problems that I want to solve, and what are the possible solutions that I want to share also with you? So in the field of chatbots or virtual assistants, and in general applications that depend not only on code, but also data, there are some different needs that the traditional software development lifecycle. Let's take a virtual assistant or chatbot as an example. Here we see that we need to do two things. We need to track code. For that, we have version control systems. Let's say in this example, for a regular and easy chatbot, it can be a neural network that is predicting intents or keeping track of some state machine dialogue management written in Python. That code can be tracked. But also, we need to keep track of the data with lots of dialogues, sentences. Nowadays, that is becoming, or is already very popular to use pre-trained language models. So what we do is that we take a language model already trained, pre-trained, and we fine-tune it with our own training data. So all of these things, the data and code, they need to be tracked together. This is where one of the main difference in the lifecycle of creating an application that has dependencies on data. And I want to show you today how we can leverage DevOps practices in order to make this easier and put it faster, those models and applications in the hands of end users. So as I said, the challenges can be and are, first of all, we have to track data. And what is one of the things that happens with data is that it changes fast. It varies in volume, velocity, and even veracity. This is something that can happen. On the other hand, when we track code, this is something that we already have experience and we have been doing using source code management tools or version control systems, such as Git. And code is made, it can be tested, and when it's written, you expect it to be there for quite some time. That's not the case of data. Data can change in hours, in days, depends of the use case. So at the end of the day, the goal, what we would like to do is that there are two tracks, one the data and the other one the code. And what we want to do is that keep the history of these two as close as possible together, because our application depends on code and data. So there are tools and there are practices. I'm not giving you the full answer. I will not say that using DevOps solves this challenge, but it's a good start where we can, let's say, divide this problem and start working on it using tools that have improved and tested. So it is not only an application that has dependencies of data, such as machine learning algorithms, applications powered by that. In general, the challenge is that whenever we have an idea, we should be able to put it as fast as possible in the hands of the real users or end users. And this applies to every application. And today I want to show how by leveraging these practices, we can shorten this time and put our ideas into the hands of our users. Now, technology-wise, what are the challenges that I was presenting? Git was created to track code. It is not necessarily good at tracking data sets and models that they can be huge. So this is why we need some other tooling, and this is one challenge that is present today. Also, we need to allocate automatically and very fast hardware resources to automate tasks that are part of the development of an application that has also data dependencies and serve the application faster. it will be, and it is very challenging in a company if you ask someone such as a data scientist, please be able to configure your own Kubernetes cluster because we want to wrap your model in a container, put it in a pod, and serve it. This is not necessarily the skill, but the idea is that when we can automatically allocate these resources, the data scientist, in this case, let's say the one that is working in the algorithm for a conversational agent, can focus his or her time in improving the algorithm and not dealing with infrastructure. So some time ago, when I started this quest of learning DevOps and applying it to machine learning applications, the question that I wanted to answer to myself was, how can I automate and deliver faster? And once I was able to automate and deliver faster applications that have data dependencies or that I am using machine learning on them, I realized that the real question is, okay, and how can I also scale? Because we need to be able to scale. There are different things that happen and this is where I will reach to the stories I promise, is that once you deploy the model, let's say the model for a conversational agent, in a matter of hours, you can find that the model is drifting and that the people that are using the bot, they are not necessarily happy about the predictions or the intents that are being predicted. So you need to scale, which means not necessarily in resources, but maybe you need to add more training data faster than you were doing it with manual steps. So for that reason is that I decided, okay, let's borrow a page from DevOps practices and what can we learn from the community of DevOps that they have been working on how to make a delivery cycle shorter, and what can we adopt from there and put it into this type of applications. That at the end of the day, what I wanted is to focus more in training and tweaking the algorithms rather than administering or managing infrastructure. So the first example, and this is based on a real life story. What is the story? When I was learning, this example is in English, but there are several language models. But when I was, in my case, at some point in 2019, I created a chatbot that was training a language model using only check sentences. And what was the reason that I did that? Because I was shy, maybe because I'm quite an introvert person. I was shy to use the check that I had, the little words that I knew, with real people. So I say it would be nice if I could have a chatbot that I can use to chat with it. And I am not afraid of maybe making some grammar mistake. Also, that's my learning style. I learn better when I write and I see what I'm writing. Then when I hear it, it makes sense. But first I need to see it written. So in that case, what is the idea here? In this country where I live now, in Czech Republic, there are people that they also don't, the official language is not English. And there are people that they are shy to speak English with foreigners. So I said the same principle applies, that my principle of being shy to speak Czech applies to different languages, and it doesn't matter the nationality. So what if we can create a sparring partner? Let's say some chatbot that will not judge you, that you can try it, you can chat with it, and it will be okay. It will not, if you are shy, that you don't want to maybe make some mistake, this chatbot will not judge you. So what is the idea? For example, I was trying it today before this conference, and what I'm doing here is that I am using a language model that was trained to be able to have open dialogues, which means that I can chat with this chatbot in English about pretty much anything. So I was telling the chatbot that I am speaking at a conference today, and it was asking me if I am a professional speaker. I don't think so. So what it said that's too bad, that if I have any hobbies, then okay, yes, I actually have a hobby. And that's what I named this chatbot as sparring partner. So how did this happen, and how I can show you, okay, this chatbot is affecting my self-esteem. Now it's asking me, have ever boxed professionally or just for fun? So it made me admit that I'm not a professional speaker, and now it's making me admit that I'm not a professional boxer. So let's go back to this. And so how was this built? So let me show you, and with this, we move on in our slides. So building this chatbot if I want to quickly iterate, maybe make it more compassionate and not asking questions that will put me in the spotlight, I can, this is the process, and this is how I can start changing it and iterating faster in this model, in this chatbot. So here I wanted to follow industry patterns. And what does it mean? That I wanted to have one project, you can think of a project in Git, that will have only the code of the application, meaning the application that you saw with the UI and the chatbot behind, that I will build this image, I will test it, and then once the tests are successful, I will push the image to a container registry. And then from there, I want another project that will be in charge only of the deployment, to take the tag of the image that passed all the tests and take that tag, update the manifest files that are the ones that I'm sending to the ones that the Kubernetes cluster will read, and then update the project manifest. I have a Kubernetes cluster that is all the time monitoring the project, and as soon as it detects the change, it will deploy a new version of the chatbot. So let me show you how does this look like in practice. So this is a group where I have here, where it says virtual assistant. You can see that this is basically the code of the application that I was using to chat. When I click here, I have all the code, what is made. I have the UI, the different endpoints that I'm consuming, the Docker file of the application. This is what I use to build the bot. And now what is interesting here is that when we go to the YAML file in the GitLab CI, this is where I am automating the process. This is what is making my life easier, because if I want to change something in the application, this pipeline will start and it will automate and allocate the hardware resources that they were mentioning that it's a challenge before on my behalf, and I will just make sure that the bot works. So here I'm building the image. I am testing in some endpoint that I created in the image to know that it's healthy. And then I am triggering another project that will be in charge of taking the tag of the Docker image that is built and that passes the test here. And that other project that is the one in charge of updating the manifest that Kubernetes will read is this one that is called GCP deployment. So you can see here that, again, if we go to the YAML file of this one, or the CI pipeline that I have defined for this project, the first thing that it does is to get the tag that was generated by the other application, update the Helm charts, and then push to this repository of this application. And this is what at the end of the day, the Kubernetes cluster will read and will say, oh, the manifest changed, so I need to deploy a new application because there is a new image. More visually, how does this look like? So let me show you a pipeline that was triggered before and where I can showcase these steps. So here in a more visual way, we can see that there was a project that comes, another project that was in charge of building the image. The test passed with some warnings. And when all of these things were okay, the other project is in charge of triggering the different jobs of this one. So you see that now this pipeline that says get tag, update manifest, and deploy, it started automatically because the virtual assistant project was able to trigger this pipeline, indicating that there is a new image. And then when this project, the env deployment, it started automatically, it was able to update its manifest files. So what does it mean? For example, here I have the different values that in Helm. And what happened here in this case is that I said the new image that I built, it has this new tag. So all of these things happen automatically. I built a new image. This project went to the other project, basically what I have here. And it updated the manifest, and then it served the bot in the staging environment, ready for me to use. That is this application that I was demoing to you. So this is one case that I would like to know if someone in the audience can tell me what is that the industry is usually calling this type of pattern. I know there are names, and I don't want to enter necessarily into the discussion of being purist, but this pattern has a name. And what are the things that I'm doing with this pattern? I am also implementing in the DevOps platform in GitLab a multi-project pipeline because I want to have isolated the code of my application from the code of the project that is in charge of updating the manifest files. So this is what I use to do that, a multi-project pipeline. All right. So another thing is that, as I said, there are different language models that you can use. So this is one in English, just for demo purposes. So now the second story that I want to share. I don't know if FAQs were ever great. So that's what I say, less boring. And what is the use case that I was thinking here? So this one is a little bit more complex, and less for fun, less for your own personal purposes of learning another language. But what this one is about is that, have you seen that there are many websites that they have an FAQ and usually it's boring to read that. So what if we can take and the application, for example, let's say in this case, it was a demo for a website about GitLab. And we take all the information that is in the website. We train a model with the data, with the pages, with text, and then we can train it to ask general questions, open questions about the content of all the data that we input in the model. So in this case, this is just a prototype where I loaded a lot of blogs about GitLab, and then I was asking that, what is GitLab? And this is what the algorithm learned with a 76% of probability of confidence that is a one DevOps platform. So how this did happen and how is this made? So this is the project where I have this, let's say, bot that is a Q&A bot. And now let me show you different pipelines. I have different pipelines here. So here in this one, I am doing different things that are slightly more complex. So one of them is that, first of all, I am cleaning the data because the data that comes from the websites, it has HTML tags and different things that I don't need to train the model. So I am doing this, I did a web scraping, now I am cleaning the data. I want to check because this algorithm that I am using, it says that it needs a minimum number of words to be able to train the model. So I'm in this data check, what I'm doing is that once I clean the data, I am tokenizing or dividing word by word everything I found, and counting that I have the minimum amount of tokens or words that I need to train the model. So this is a test that passed. So I can say, okay, I can move on. I do other different tests of security that I'm adding security vulnerabilities. These are more the software engineering tests, the traditional ones. This is more of a machine learning like test. And these ones are the ones that I am checking with SAS scanners and so on. Then I will build the model using the data that I just loaded and deployed. So this is what's going on in this application. So let me show you now how it looks like when we go to the YAML file, because there are different things that I want to highlight here. First of all, as I said, when we use platforms, is that we can extend them. We can add different things. So one of them that I can use here is this library that is called MLflow, that it helps me to be able to replicate my experiments easier. So what I'm doing here is that every time that I want to run this script that is checking if the website is the data, it has the minimum amount of tokens or words that I need, I am just running it with this MLflow run, which means that I already have a script that knows what to do. What is the advantage of doing this? That if you were to clone this project and you want to test it, you don't have to suffer from dependency health. You just say, okay, I have MLflow, and MLflow will run this script and it will tell me, it will create this output artifact that is the one that the neural network needs in order to learn. So these are different things that I'm using here. I am leveraging other open source libraries in order to make the experiments more repeatable, more reproducible. So here I am doing the same. I have a script that has all the dependencies needed in order to do the data check. And now I'm going through building the model and deploying to different environments. And speaking about different environments, here is where it's very interesting to see different things. software engineers and people in general that they work with different software engineering or development of applications and data science and machine learning engineers, we are all familiar with the merge request or pull request flow. And what we can do here is that I can treat my application with software engineering practices. So let's say that I want to add a change to the code of this application. So I create a merge request. And one of the cool things also when it comes to Kubernetes is that once that I pass all the tests, I can also have an ephemeral environment that is called review apps, that this ephemeral environment that you see here is one that was created specifically with the code changes that I added to the application. So this allows me to use the application and test the model in my case. I find this very advantageous because I don't know if you have seen that usually when they try applications like these ones that are with bots, the results can be unexpected. The accuracy of the algorithm or whatever metric you are using to measure, it can be good, but if you ask something to the bot, it might give you some comment that is not correct or that is full of hate or something. There are cases in which the bots somehow, based on the data, they learn how to say things that are inappropriate. So one of the things that is important here and that I like to take advantage is that by having this integration of software engineering workflows, being able to create an application that has the changes that were created via a merge request and deploy it to an ephemeral environment also give another type of users the chance to try to chat with the application, ask different questions, and see if the answers are appropriate in this case. So this is one of the things that I am also using bots to make FAQs less boring. And this is a depiction of all the things that happen when I am building this application that I just showed you. So locally, the data scientist or the machine learning engineer or the developer or the hobbyist or whoever is working with these libraries, then is putting it to a remote. And whenever is pushing to remote, all of this is the pipeline that you saw is happening. I am cleaning the data, checking that I have the number of tokens, passing security scans on it, building the model, and then deploying it to a Kubernetes cluster. So there are different things here that are worth mentioning. I am using, in this case, a GitLab runner that is a standard share machine. But if you wanted, you could enroll your own machine, your own runner, that it can be either in the cloud or your own computer with a GPU. So I have tried pipelines like this, where, for example, in training the model, I am using a specific machine, which is a GPU enabled, just for that step. And then shutting it down. So it means that data scientists or whoever is using this, they don't have to worry about the bill of turning off a virtual machine in the cloud that is GPU enabled. Right, so these are the different steps that we follow. And now some honorable mentions, and with this I will close. These are older projects that I've been working and I wanted to quickly mention. One of them is related to Dragon Ball, that is huge in Latin America. And is that I was a fan, I am a fan, and I knew a lot of things about it. My mom, she works as an educator of kids that they have autism. My mom was telling me that one of her students, he didn't want to read, that whenever they were chatting or something, he was sending audio messages. So I was telling my mom, because the kid also liked Dragon Ball, what if we create a bot like these ones that you have seen, that is a trivia bot asking questions or saying things about Dragon Ball? Maybe he will be more encouraged to read. So we tested the idea. Before that, this was in 2018. I didn't know anything about DevOps. And the time it took me to build the application, create the endpoint, the virtual machine, put the application, install Nginx, doing all of this stuff, putting it in a Docker hub, pulling tokens. When I was ready, my mom told me, oh, he doesn't care about Dragon Ball anymore. He likes Fortnite. So if we want him to read, we should change the topic. And I said, oh, too late. I already spent a lot of time doing this. I don't want to start again. We did it eventually, but this was when I said, okay, there must be a way to be faster when we want to deploy this application. In this case, the key changed interest. Now imagine what can happen at the scale of companies and the cost of being slow. So one idea that also occurred to me is how can we enable someone that is not me, because in this case, I was able to explain, I was able to create the bot because I knew about Dragon Ball. But when I was saying about the scaling and using DevOps, is that in that case, my mom was the one that knew him better. And I wanted my mom to be able to collaborate with training data. She didn't, I couldn't ask my mom, can you please fill this YAML file? Even engineers, they suffer with YAML. Now imagine that my mom, that she's not an engineer, trying to keep the spaces. So what we did is that we use a spreadsheet with this table that my mom was able to fill. Everyone can do this. And then what I was doing was a pipeline that was, whenever there was a change in the data, we were triggering a pipeline that was taking this table, converting it to YAML, and then passing it to the model that needed the new data to be retrained. So let me show you how it looks like. So it was basically something like this, that we are reading, we are monitoring Excel from Google, and then we are pulling the data from there. And once we have the data, we trigger the creation of a model. And remember that I said that there were different challenges, such as keeping track of large data sets. So one of the things that I was using for this project, first of all, the library that I was using, an open source library for chatbot that is called Rasa, and DVC, that is an open source library as well, that helps you to keep track of data sets and also serves as a model registry, meaning that all the things that you do that are data related, they don't go to Git, but they are monitored by DVC. So you don't push models and you don't push data to Git. You keep track of it like if it was Git using a hash, but using DVC. One of the advantages of this is that, as you can see here, when you want to push code, you do Git push, and with DVC it's similar, DVC push, DVC pull. So the learning curve should be shorter, because if you know Git, then you just replace Git by DVC, and you have the tracking of data and the data version control using this open source library. So before I conclude, I want to show you a final thing, which is how this bot, the one I was mentioning before, was being deployed. So this is we have 5 minutes. This is another pipeline where what I was doing was going through all the stages in which I was reading the new information or data that my mom was collaborating and using it to create a new model and deploy it. And with this, I close. I want to show that these libraries like DVC, they help us to have, this is for the data scientists, this helps us to have the information that a machine learning engineer or a data scientist would need in order to approve a model that goes to production right in the merge request. So as you can see here, when I create a model and I train it, automatically the metrics that are out of the training, the accuracy metrics or performance metrics, they will be automatically added to the merge request. Because in software engineering, a test can pass, yes. In machine learning, it can pass because the code is correct, but maybe the data distribution and the predictions that we are seeing are not the best. So we need to bring these two together. With this, I start closing, and I wanted to say that by using and adopting DevOps practices, I didn't give you the whole answer. There are more things when it comes to this field of MLOps. We can start focusing more in doing better, using better training data, for example, debugging our data, and focusing what we would like to do. In my case, I would like to focus more in the algorithms of the language model rather than the infrastructure. By utilizing this, many things are automated and done for me. At the end of the day, this allows us to deploy faster and test our ideas way faster. Thank you very much. So I am open now for questions. One question is, how does MLOps is different from DevOps? So this is a very difficult question and a very good one, because I don't know. This thing is new. And let's say that when I started working on this, I don't think there was the MLOps name. But one answer that is around, because this is still in discussion, I have seen it in many forums and books, is that some people say that MLOps is a subset of DevOps. Some other people say that MLOps is bigger than DevOps, because you also have to deal with data, feature stores, and model registries, and so on. I don't have a preferred one, but what I will say is that both are a philosophy, that a discipline, that what it means is we want to put this application in the hands of our end users faster, regardless if you want to call it MLOps or DevOps. What we want to do is to shorten the life cycle of the delivery and keeping it easy for the end users and also for the developers and machine learning engineers that work with that. And going broader, I was giving examples of bots that they go wrong in their predictions. When you use DevOps practices, you make your code and your data easier to audit. So in this case, by following this discipline, you are not only serving your models faster, but you also are ready to comply with different auditings that you need to go through. For example, if you predicted something and you want to show this was the model with this commit, with this version of the data, with this pipeline that generated this chatbot, you can do it. So what I want to say is that there are two versions. One says that is a subset, another one that is a bigger part of DevOps. I like to think that they are both disciplines that we need to use in order to deliver faster, securely, and better. Is there another question? All right. Thank you very much. And I hope to see you soon, next time in person. Bye-bye.